Thank you. Florian and David, a warm welcome to you. And I'm looking forward to the interview today on Thermonet and getting to know more about you and your products. So perhaps you would start by introducing yourselves. Maybe David, you will start.
Yes, thank you, Marianne. We are very happy to be here. My name is David Kuntz, and I'm one partner at GeoAlto.
Yeah, my name is Florian Schwinghammer. I'm the second partner. And yeah, we are thankful to have this interview with you.
Thank you. And we are looking very much forward to learning a little bit more about you. What's your background, first of all?
I have studied geoscience or geology, and also made wrote my dissertation in this field. Have been a geothermal project engineer since 2008, and been working more or less exclusively in that field since I finished university.
Interesting. And what about you, Florian?
Yeah, I'm a hydrologist, Master of Science, and I'm also working in the field of this shallow geothermal systems for over 10 years now. Wow. So I've also gained some experience in the last decade.
Yeah. Okay, and then you have together founded GeoAlto. So let's get to know GeoAlto better. What is GeoAlto about?
Should we do that with our slides or beforehand?
Yeah, why not?
In person?
Yes.
Okay, so
Which
maybe
slides?
We have prepared a few slides about GeoAlto, who we are, what we do.
Yeah.
And I'll just share them.
Please do so.
Florian and I will talk a bit about it.
Good.
Right. So now you just tell me when you see everything.
It's there.
And you're faster than me. Right. Florian, if you'd like to start, I just go to the next slide.
So GeoAlto, who we are and what we do. There's a transcription from our website. GeoAlto, we stand for sustainable heating and cooling with energy from the earth, like geothermal systems, mainly, as we already stated. And yeah, for us, it's a key role in the heating and cooling systems of the present, but also, of course, for the future. It has all year-round energy source that is quite untouched by all the things that are going on in the world. And so we now, about 5 years ago, we started our company, and we also have our projects with this Thermonet, which we call in Germany a bit different, but directly translated low temperature local district heating. And with our consulting, we managed to create some geothermal heating and cooling systems that endure and are produced for now and also for future generations.
Sounds good.
And maybe this slide we already talked a little bit about us. We don't want to talk too much. As I said, I'm a hydrologist. David is a geologist. Maybe our colleague, Louis Holstein, he's also a geotechnical engineer. He's with us since 2023. And we have a little bit divided our fields of working a little bit. We do all the same, but then also we have our main focuses. For me, it's for system design, exploration, bid invitation, and then especially also the construction supervision. David?
Yeah, I do more the theoretical stuff, like feasibility studies and simulations. Also, I am for a couple of years now a publicly appointed and sworn expert for shallow geothermal systems. So we also consult jurisdiction or law when there is the need. Together, I think we reached 30 years of business experience, didn't we, Florian? Something like
Louis,
that.
Definitely.
With Louis, definitely, right.
Yeah.
Okay, we'll show in a few slides what we do as a business. On the basis, or most of what we do is based on our understanding of the movement of water and heat in the subsurface. Decisions and design regarding underground heat exchangers are usually began with the geological or hydrogeological model of the ground and hydraulic and thermal simulations of the changes introduced by the geothermal system. We use various analytical and numerical approaches to model the short and long-term thermal response of the geothermal system, and one aim can be to ensure an efficient and sustainable economic development of system temperatures and energy potential over many years. Or we can also use these models to assess the size and extent of underground temperature plumes, of which some examples are shown on that side. And based on these, of course, we can design all kinds of underground thermal systems, of which Florian will tell you a bit more about in the next slide.
Here you can see also some drawings and pictures from our reports that we usually create about the thermal and hydraulic designs of geothermal systems. Like on the top left, you can see some heat distribution from some groundwater wells. On the top right, for a closed system for EHEs, the thermal and answers of the underground. And then also you can see some details which are provided during the planning and construction consulting process, which are also going into the construction site.
Yeah, a couple of years ago, these geothermal systems, where we come from, increasingly were built as heat sources and or sinks, of course, for decentralized heating networks. And that's basically what a thermonet is, right? Florian already said it. In Germany, they're usually called low temperature or cold local heating or cooling district networks, but it's more or less the same term. And since these pipe networks usually are uninsulated and in direct contact with the underground, they somehow fell in our area of competence since we are working with pipes in the underground. So beside the thermodynamic simulation of these interactions between pipe network and ground, we also extended our area of expertise to the hydraulic simulation, so we could design the whole network from one end to the other, more or less, which makes sense since these systems usually are hydraulically intertwined or connected with a core geothermal system, and we consider a thermonet part of the geothermal system, and thus we extended our area of work to these networks. As you can see here, we design also the hydraulic network with and the thermal interactions to the ground. So that you could call this the core competence of our company, designing systems in the underground. But we not only do the design, we do everything in the planning process from the beginning to the end. That starts with feasibility studies, site evaluation, exploration. We plan and design it, what we just showed you, and then we consult our customer with a call for tenders. And of course, then we go into the realization, and we also do the on-site supervision and the technical construction management. And once the thing is built and in operation, we maybe come later to that again. We also monitor and monitor the system, evaluate the development, and compare it to what we designed it to do, so we can give the customer anytime or every time a clear idea of whether the system is running within its design parameters or if something is off.
So in that way, you could say that with GeoAlto, it's kind of a one-stop shop because it's from the beginning until it's up and running that you actually are helping?
Yes, but consulting only. We don't do the construction ourselves. So it's a one-stop shop if you need advice and someone who can tell you how to do it and how expensive it will be or whatever. But of course, we don't build this, or we don't do the actual work outside.
No.
I know we do the work outside, of course, but for supervision only, not for construction.
Yeah.
Yeah, so that's mainly what we do. We assembled a lot of photographs on the next 2-3 slides just to give an illustration a little about what we do.
Yeah.
I think, Florian, did we say something about exploration?
I think it's more my field, so I will take over.
More your field, right?
Yeah, exploration, assessment, thermal response test. Here you can see some pictures about these topics. Yeah, the exploration usually consists of drilling a borehole in a combination, of course, with a closed system with BHEs, borehole heat exchangers, examining the geological structure at the site, constructing a pilot borehole heat exchanger, and conducting a thermal response test on that BHE to measure the thermal properties of the subsurface. Yeah, and here you can see like the drilling itself, that obviously is not us, but the other companies that we are working together with. And then on the other pictures, you can see our measurement tools for these thermal response tests, and also then some result drawings from our reports, where you can see temperatures from the underground and also the thermal response to the heat conductivity results. What is not shown is for open sources like groundwater wells, where we also can provide some measurement tools, but also not doing the drilling itself. Yeah, and yeah, there are some other pictures, like not only the exploration, but these are now pictures from the real construction site when everything is, the consulting is already done and the planning. You can see some pictures from some bigger projects which are on closed construction sites, where you can see on the top down left, can get quite crowded when there are a lot of machines at the same place, and but it also, yeah, when the working things are going quite well, you can also have pictures like on the top left where everything, yeah, it's not that crowded. And in the middle on the right, the drilling is already done, or yeah, on the top you can see a ground collector, and on the right and on the down middle you can see the manhole or the system to get through into the buildings and distribute and provide the heating.
These were very interesting projects for us. We did prepare a few slides towards a thermonet. Marianne asked us beforehand, what's the project we like the most?
Exactly. What are you most proud of? Yes, yeah.
Most proud of. We, of course, Florian said we're proud of everything we do. That's true, of course. But the next 3 slides will be about a thermonet we planned a couple of years ago, and it's in operation for a couple of years already. We are collecting lots of interesting data about it. I'm afraid the slides are in German because we took them from our German spoken reference projects. Florian was the project lead at the time we did it, so I'll leave it to Florian to explain a bit about it, but maybe here and there I can jump in for some parts I supported.
Yeah, this is a thermonet in so-called Königsmoos. With our 2 thermonets in a smaller area, with in total 72 houses that are connected or are planning to connect with the thermonet. with in total 350 kilowatt and 630 megawatt hours per year. It's a passive thermonet, so to say. There is not a main or a centralized pumping station or a heating station, but everything works with the decentralized heat pumps of the certain customers. There was also some sponsoring of this. It was called Thermonet 4.0, which the construction site got also some money from. As David already said, we are also monitoring the systems. It's quite interesting to see how from the consulting, from the planning, it goes to the real field and the real working heat pumps. And the total cost of these two systems were about 1 million euros without tax. We did mostly everything, but especially the phases 5 to 9, the HOAI German, that's a German regulation on the planning steps. Also the hydraulic of the system, as we showed before, and also this monitoring technology. Special challenges on this project was that it was constructed, or it works with borehole heat exchangers, and the depth was quite limited to 65 meters, which is some special regulation in this part of Germany there.
The fields are rather large.
Yeah.
We have, I don't know how to say it in English, but everything is connected, the whole thermonet. It is not like a one-way net, but we have different cluster for each thermonet. So everything is connected, hydraulic. And we have a variable technique for all the customers to connect to the thermonet. And maybe what we haven't written here, but what was also a big challenge here, the groundwater level was very, very high. So that was in the construction side. It was, very challenging, but that's a special thing.
Interesting, yeah.
And here's some pictures or drawings from the consulting and planning pathway to the finishing line. Here you can see some drawing of the where you saw some drawings of the maps for all the borehole heat exchangers and the pipes connecting them to some manholes. And because of the high groundwater level, we also had to plan or construct the manholes specially. You can see also from the hydraulic perspective some pressure losses for all the houses connected, because in the end you have to provide that it's working for every household. And I think in the next one you can see some pictures about monitoring where David is saying something.
Yeah. We had a separate slide for this, but included it here because it was included anyway. I wanted to say, as a planner, we always have an interest in verifying that the systems we design run as we design them. And in the last decade, getting data on how geothermal systems run was a problem, because the system in generally runs so good, no one sees the need to measure data. But systems nowadays getting more and more complex, combining various heat sources, heat sinks, cold sources, cold sinks, and especially these thermonets are something new entirely. So we designed not only the measuring systems or sensor technique or sensors to get data, but also developed our own cloud monitoring stack on which we gather the data, evaluate it, visualize it, and are able to send out automated reports not only to ourselves but also to our customers. And the picture shows a few dashboards and reports we generate out of the system, and we are very happy that we now are able to get real-time data on what is going on in the system, and also we save the data, we never delete anything, so we can evaluate over many years of operation if there are any changes or trends, which is important in geothermal systems.
Yeah.
Yes, and on the last slide of the project, you can see some pictures also from the construction side. Like on the right side, there's still a drilling going on, and then most of the pictures are from the horizontal piping, and also the specialized manholes, and also one manhole to divide the thermonet in case of a spill or some leakage. It's also important to be secure in the construction, also in the use of the thermonet.
Right. That's about all we do.
Good.
Or that's about most of what we do. Of course, there's always more.
Yeah. Interesting to listen to. I mean, some says that this is a new thing with Thermonet, and others says no, it's an old thing. I mean, we have Thermonets from the 70s back in the Ruhr district and elsewhere, and it's like we know the pipes, we know everything. It's just put together in new ways, but it seems like it's not always that legislation is following through with projects like this. But when you do your projects, what would be some of the challenges you mostly meet, and how do you overcome them?
You or me? Well, let me start. One thing is, Florian said it, hydraulics, especially these decentralized networks where a lot of very small pumps are connected together to move a lot of water in these networks. And a lot of people cannot imagine how such a small high efficiency pump with maybe 20 or 30 watts of energy consumption, or well, not one, but 70 or 80 of them, should be able to move hundreds of thousands of liters of water in these systems. But they do. It's possible, and you can calculate, simulate it, and do all that in advance. And this is, well, one challenge that is brought to us from our customers, but which we can easily, or one fear which we can easily dissipate by just showing them it's been calculated, it's been done, and physics say it's working, and experience says it's working, so it's working.
Yeah, and you can prove it. Yeah,
we can prove it.
Yeah.
And one other thing is, these systems are usually not running with water alone, but there is some refrigerant mixed in to make it stable even below 0 degrees temperatures.
Yeah.
And these refrigerants are substances considered slightly hazardous to water. And that makes the whole system a system which is hazardous to water. And this falls in Germany under special regulations, and these regulations have been challenging in the last, or since these types of systems are coming up, and they still are. We have now compromises and solutions, but still it's a challenge to get these solutions, or to make these solutions known, or to get everyone to agree on this proposed solution. But we're on a good way in this regard.
Good. So is it case by case approvals that you get? You work with Thermonet, or?
Yeah, in Germany, the water rights are approved by, in every district has its own own way. So and since everywhere are sitting people deciding something and having a different opinion, it of course is a case-to-case decision most of the times, especially with thermonets, because they are still considered new.
Yeah.
I mean, there are still like regulations that are that are counted, getting a count everywhere in Germany, but like the small things, as David said, there are human beings sitting there, and sometimes they decide like this, and sometimes different.
Yeah, I understand. Yeah, it was really interesting to listen to your all your knowledge and your projects and what you do in GeoAlto, and now you're also a member of Thermonet Europe. And I was wondering, what would you like to gain from your membership? What are you looking for?
Yeah, we'll just start with, of course, we are happy to be in this surrounding, and of course we want to connect and share our experiences, as you saw, with a lot of projects, also with international colleagues, which was also very interesting to see how it is done in Denmark or also in other countries. And of course, the Thermonet system itself, like the principles, as David said, sometimes it's hard to imagine or to think about it, how that it is working, and also to kind of propagate these systems and to customers, and to practice, and also the politics to show them how it's done and that it can be done.
Yeah, I guess for experts like you, it's like a no-brainer, but you have to be able to explain it to people who actually don't have the same expertise, right?
Everybody has its field.
And especially experts sometimes are fighting to get their opinion acknowledged. And the more we are, and the bigger the community is, and to see that others are fighting with the same challenges, and maybe someone has already had a solution or a good argument or a discussion, that makes a lot of it easier if you can just see there's more of us driving this in the same direction, wanting the same goals to be reached. And that's very comforting, seeing it's not only something we're doing alone, but something we're doing together.
Yeah. I think that actually leads very beautifully into the last question, David, and that's about the future of Thermonet. So how widespread do you think it will be in 5 years from now? And why, if you think so, is it important that Thermonet succeeds?
You mean Thermonet as a concept or Thermonet as an organization?
As a concept, yeah.
We are and have been repeatedly in challenging times ensuring our, energy independence, let's call it that. And anything related geothermal is a significant step towards energy independence. A Thermonet is just one of many possible ways to utilize geothermal energy and to make it available for a larger user base without every user having to become an expert. Making a Thermonet makes it a no-brainer. You just buy your heat pump, connect to the network, and that's it. That's it. And so this, for us, it's an important part of becoming energy independent, and it should never be dropped, not in the next 100 years.
Anything to add, Florian, about the future of Thermonet?
I see this is of course the same way, and I think in the future, that the challenge will be that not only new housing Thermonet systems will construct, but also like in the already existing housing areas, and that is more challenging. We have also now projects that are going on right now, which are on existing housing, and that is should be more the focus on it, because there's already so much existing, and that the translation from old heating systems to Thermonets, that's the goal.
Yeah, sounds good.
Let's add, Marianne, that our a challenge has been and will remain to be to get groundwater protection as a source for drinking water, which is a #1 priority, no question about it. Bring it together with energy usage of the underground. So we have these two resources underground, energy and drinking water, and these two need to coexist. And to get that together somehow will and is still our challenge, I would say. But
Yeah.
we're on it.
Yeah, you're on it. Yeah, that feels safe then. Yeah. Very interesting. Thank you for joining for this interview and letting our members know more about you. So I would like to thank you very much for your time here.
Thank you too.
Yeah, thank you very much.
Yeah, you're welcome. Take good care.
Bye-bye.
Bye.